Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, welcoming you to the next in our series of what to look for in the night sky. We're talking about the week of May 1st, 2023 this time around. So let's jump right in it. Last week we talked about something new for each night of the week, something to think about as the week progressed. This week we're going to dive into one region of the sky, something we do a little bit more typically. We're going to look at the stars of Virgo. A couple of reasons for this. One, the moon's full this week, so the moon is waxing toward full, big and bright, washing out a lot of things that we would like to see in the night sky. So we want to focus on stars and think about the stars that we can see. Plus, the moon is passing through Virgo, so it's going to guide us to some of the stars in Virgo. And with the moon approaching full, that means Virgo is rising before it gets dark and up most of the night. So Virgo is really well placed for observing right now. So let's jump in and talk about some of the stars of Virgo. So a lot of times when we do Virgo, we talk about this, you know, you've watched these videos, you've seen me talk about this a fair amount. We just throw up a sort of Y shape and say, yeah, here's a vaguely Y shape. So I've tried to be a little bit more precise here, and then I wrote it all over it so you can't see anything. It's what I like to do. Spica is the brightest star in Virgo, and so it sits at the base of this Y right here, with Porrima, a star that we'll talk about a little bit this week that we've talked about before a fair amount, so we won't spend a lot of time with Porrima. But we move up this direction. There's our Y over here, sort of up this way and that way. And so we're making the shape of the bright asterism of Virgo look something like that, with Leo, the triangle tail of Leo sitting above there. And then we always ignore, for whatever reason, we spend a lot of time ignoring the stars that are back off this direction in Virgo. They're fainter. A lot of these stars are pretty faint, so that's why we ignore them. If we draw a line, so let's actually stop for a second. We'll come back to this. Let's just start the week on the evening of May 1st into the morning of May 2nd. So overnight of May 1st to May 2nd, Monday night to Tuesday morning. The moon will be about 85, a little more than 85 to 90% full for me that night. It depends where you are in the world, of course, what time it's dark and you're out looking at this, just how full the moon is. But for me, here in the middle of North America, it's going to be about 85 to 90% full on that night, and it's going to sit within a few degrees. All of these moon passings of stars that we have in Virgo this week are all within 3 degrees, and sometimes within 2 degrees. So they're nice close pairings of relatively bright stars with the moon. So that in and of itself is worth watching. So on the night of the 1st into the 2nd, the moon's 85 to 90% full, and it sits just to the east of Zavijava, this star that's coming up the right branch of the Y of the Martini glass of Virgo that we look at. That's the beta star. And so we'll take a moment to remind ourselves that we give Greek letters to the stars, and they're more or less brightest, starting with alpha, beta, gamma, delta, and so on, in order of brightness of the stars. And it's only more or less. We don't do a great job of, oftentimes the beta star, sometimes the gamma star will be the brightest star in a constellation. And as you get further through the Greek alphabet, it becomes less and less accurate whether whether one star is brighter than the other star that you would expect. But this is the beta star. It's a pretty bright star up the branch of Virgo this direction. Most of these stars are somewhere between 3rd and 4th magnitude. Up the epsilon up the other side is a little bit brighter. But we have these stars that are between 3rd and 4th magnitude, relatively easy to see, or just over 4th magnitude, but not trivial to see. And with the full moon there, they'll be washed out a little bit more. But this is the moon sits here so Porrima is the gamma star, Spica is the alpha star, between beta, Zavijava, and the Porrima is Zanaya, the Eta star. So you can track down. You find beta, track to Eta, and track to gamma as you're watching the stars. Now let's move on up. These are fainter stars up to the north here. But while we're here, we might as well work straight, turn straight to the north and see if you can find Nu and Omicron to finish that branch of the Y of Virgo. By the next night, the moon will have moved and be sitting right here next to Porrima on the night of the 2nd into the morning of the 3rd. And it'll be 90 to 95% full. So it's really getting full at this point. So the moon will have filled out a fair amount and be sitting close to Porrima. We talk about Porrima a lot because it's so close to the ecliptic. The moon goes by there a lot. Planets will go by there a lot. It's a big, beautiful, bright star that planets go by. And it's a binary star. So if you've got a small telescope, it's worth the time to get it out. We've talked about this several times before because stuff just keeps scooting through this area and reminds us of Porrima, but it's one of the better examples of a binary star that you can see in the sky. So it's a great double star to be observing with your telescope right there. So it's a great thing to do this week to think about that. Now, by the night of the 3rd into the 4th, it'll be down here by the bright star in the region, Spica. Spica's big and bright relative to everything else. We use the handle of the Big Dipper to arc to Arcturus in Boetes, and then we spin on down to Spica in Virgo here. And Boetes to Spica, the handle of the Big Dipper to Boetes to Spica, that's a stretch, that's a run of bright stars that we see there. So these are all pretty good stars, and so Spica's a good bright star in the region there. So all is good. All this is good. And so you want to watch the moon track out. By this time, the moon's almost full. It's over 95% full for me by the time it gets here on the night of the 3rd into the 4th. But let's move back up. And as we go up the left branch of the Y of Virgo, we get to Delta, and then we get to Epsilon. And as we move up this direction, if you make a right triangle that looks something like this, like that shape right there, with delta and epsilon, you're sitting above about 8 or 9 degrees, almost due north, almost straight above. So about a fist width straight above Porrima is the star that's often labeled R. And R Virginis is a pulsating variable star. And it's of a Mira class. So we talk about Mira class variables. And this is a Mira class variable that has, okay, let's talk just a little bit about this. So this star is, let's just take a break. And oftentimes astronomers draw something called an HR diagram. It's one of the more important diagrams, and my students are sick of hearing about it right now. But on a diagram like that, temperature increases to the left this direction, and luminosity, brightness of the star, total energy being emitted per time, increases up this direction. And stars start their lives on the main sequence here. And so we have a zero-age main sequence that we can draw across there. When they leave the main sequence, stars that are on the main sequence are sort of quietly fusing hydrogen into helium in their cores. That's where the energy's coming from, right? They're emitting a lot of energy out into space. So the stars are really, really, really emitting a bunch of energy, and if there weren't something replenishing that energy, they just cool away and disappear very quickly. But they don't. We see them, so we know they're there. And what's for these main sequence stars, where stars spend most of their existence is on this main sequence, that energy replenishment is coming from hydrogen being fused into helium deep in the core. And that core is pretty small relative to the whole star. And when you run out of hydrogen in the core, now you can replenish it through convection. You can convect some hydrogen from out here down into here, but we don't need to talk about stellar evolution too much here today. I mean, I know you're begging for it. I know this is why you tuned in, was to think about stellar evolution. But then they become red giants. And so a star will leave the main sequence and move across here and go up the giant branch. So red giant branch, let's call that. Red giant branch stars up this direction. And at that point, what's happened is the stars run out of hydrogen in the core. It's going to cool a little bit because it's not replenishing that energy. When it cools, it contracts. And when it contracts, it heats up. That's sort of what happens with the physics of these things. And when it heats up, you can start fusing in a shell around there. So hydrogen to helium fusion still, but in this shell. And then you're a red giant branch star. When that runs out, at some point, that doesn't actually run out, but at some point, it gets hot enough in the core that you can ignite core fusion of helium into carbon. And you drop onto something we like to call the horizontal branch. And then that doesn't last very long at all. And then you start fusing hydrogen into helium and helium into carbon in narrow shells around that core. And you ascend something we call the asymptotic giant branch back up this direction as you have the hydrogen shells and helium shell fusion moving outward. Okay, all of that's great. But what happens here, there's something called the instability strips. There are various instability strips up through this direction where the stars, if you tweak them out of equilibrium, if you tweak them out of where gravitational force inward and gas pressure or radiation pressure outward is balanced, for most stars, if you do that tweaking, they just fizzle back down to they lose energy and go right back down to their equilibrium state. But some stars get a kick of energy at just the right time. Think about riding on a swing and kicking your legs at just the right time to give you a boost of energy to keep that pulsation going, and they become pulsating variable stars. And R is an example of this. R is an asymptotic giant branch star known as a Mira star. And Mira stars have these hydrogen and helium fusion shells going on, and they're unstable to pulsation. So they tend to pulsate like this, and they tend to do so with hundreds of days of period and big brightness variation. So R Virginis gets 100 times brighter. Its brightest point relative to its faintest point is about 100 times brighter, so you can really see this difference. And so you got this going on right here, and it's one of the shorter period Miras. It only has a period of something like 145 days is its period from brightest to dimmest back to brightest. And so that means over the course of just a few months, you can see it to change brightness by a factor of 100 typically, by a whole bunch, 50 or 100. So if you have a telescope, and if you want to start taking pictures, if you have a camera and want to start taking pictures of this region of the sky, or if you just want to start sketching this region of the sky, to see if you can just see what you see, get a nice wide field and start sketching there over the next few months, I think you're going to find this to be a really worthwhile, fun project to see this variable star pulsing in and out. Now, as we go down this direction from Spica over to these stars out this way and on down this way, we pass Zeta. And as we pass Zeta, Zeta's off the line from Theta to the rest of the stars out here. Zeta's above there. But as we pass Zeta, just back down to the southwest of Zeta, sort of more or less on that line, a few degrees to the southwest, is W Virginis. And W Virginis is a different class of pulsating variable star, but the same idea. You're crossing the instability strip here. It's a Cepheid variable star, one of the more famous, a little bit more famous Cepheid variable stars as distance indicators in the universe. But this is a less common Cepheid variable star, type 2. It is, in fact, the prototype of the type 2 variable star, Cepheid variable stars. And so, but again, you're in here. So you're in here crossing this instability strip, and so you can cross it all kinds of ways, going this way, this way, this way. But every time you cross the instability strip, the star becomes unstable to pulsation. Now, this star, it doesn't change brightness nearly as much. W Virginis changes brightness by maybe a factor of 3 or 4 instead of the 100 that you get. So you're going to have to work a little bit harder to see the variability here. But it does so with a period of about 14 days. And so with 14-day period, you only got to watch for a couple of weeks, and you see it go from brightest to dimmest back to brightest. So you might see if you can poke around and find that star. If nothing else, find Zeta and familiarize yourself with Zeta and get to know these stars of Virgo as the moon slides through here this week. Think a little bit about stellar evolution, what powers the energies of stars, and how they move, how they pulsate once they sometimes cross these instability strips here. So that's what we got for you this week. Let's enjoy the stars of Virgo when they're well placed right now. The moon's going to be passing through there, so it'll be harder to see some of the fainter stars in there. But we can use the moon to help us find some of the other stars as well. And I hope you have clear skies this week. And as always, thanks for watching, everybody.